Hi everyone, this is Fahmida Alom, and today I'll be using this example to explain test for proportion, the central limit theorem, as well as the hypothesis test. Okay, so firstly, investors in IT have a historical success of 65%. So the 65% or 0.65 will be the population proportion. And then a random sample of 250 IT investors showed that only 180 were successful at alpha 0.04. Is there enough evidence to conclude that the success rate has changed? So now we can conduct the null hypothesis and the alternative hypothesis. Null hypothesis is p equals to 0.65. So the alternative hypothesis will be p is not equals to 0.65. Now we have to uh, see the sample size here is n equals to 250, okay, and 180 is the success rate. So the success rate we denoted by x equals to 180. Now, the sample proportion, which we denote by p hat, it is the hat, equals to x divided by n, which is 180 divided by 250. And so the sample proportion will be 0.72. Okay. Now we have to check if we can conduct the z-test and if it's a normal distribution or not. And for that, we need the central limit theorem. Central limit theorem says that if the sample size is big enough, then we can conduct the normal distribution and thus we can also run the z-score test. So if NP is greater than or equals to 5 and N1 minus P is greater than equals to 5, then we can say that we can conduct the z-score test. All right. So the NP here will be the sample size, which is 250 multiplied by the population proportion, which is 0.65 equals to 162.5, and N1 minus P equals to 87.5. All right. So since this is greater than 5 and this value is also greater than 5, we can conclude that we can run the z-score test. So the z-test equals to sample proportion minus population proportion divided by root over p into 1 minus p divided by n. This denominator is the standard error of sample proportion. Okay. Now, we already found all of these values here in the in these parts. So the sample proportion is 0.72 minus the population proportion is 0.65 root over 0.65 into 1 minus 0.65 divided by n, which is a sample size 250. So the z-test value is 2.32. All right. Next, we are gonna see if the p-value is greater than or less than the significance level, which is 0.04. All right. To find out the p-value, we have to do it in Excel. There's other sources where we can find the p-value, but here we will be using the Excel. And in Excel, in any cell, you just have to write equals to multiplied bracket 1 minus norm dot is dot dist. You have to remember this, the norm dot is dot dist. And in the bracket, we have to put the z test first, which is 2.32. It's the z value. And then we have to write true. Now, this true means the area will be below this curved line. All right. Now, the p-value we get after we write this in Excel is 0.0203. Now we are going to visualize everything in the graph. Okay. Now, the Z-score test, we find that it's 2.32. So the upper bound will be 2.32 and the lower bound here, the value will be minus 2.32. All right. Now, this region and this region are the alpha, or this individual region will be alpha by 2. This individual will be alpha by 2. Okay. So the alpha is 0.04. We get this from the question. All right. Now, if we go beyond this line or beyond this line, then we have to reject null hypothesis. Now, since the alpha is 0.04, if the value is less than 0.04, then we can reject. Then the p value belongs to within these two region, right? So now the p value is 0.0203. So for this region, the p value will be 0.0102, and this region, the p value will be 0.0102. We can also find this by dividing this value by 2. But since it's a two-tailed, we have to use 0.0203 to determine if we have to reject or not. So since the p-value, which is 0.0203, is less than 0.04, which is the alpha, we reject the null hypothesis. Okay? And since we rejected the null hypothesis, we can conclude that there is enough evidence that the success rate has changed from 65%. So that's all for this video. Thank you, everyone.